5 in trig, okay? Chapter 5 is really heavy algebra, okay?
Adding cosine.
Oh, you have no idea.
Multiplying them.
Okay, it is going to hone all your algebraic skills so that by the time you get to calculus, you're ready. Do I speak truth, Ethan?
This entire chapter?
Yes, I do. Okay, chapter 5 is like a lot of logic puzzles in trig. Okay, so when I say you need to keep up with the homework, I mean you need to keep up with the homework.
Okay.
If you don't get it, get help. If you want to check your work to make sure you're right, let me know. Most of this you can check yourself, but, and I'll explain how as we go through it, how to check it. But you need to be good on this stuff. Okay, so lesson 1 is using fundamental identities, and you're like, okay. So we're going to learn to write and recognize the fundamental trig identities. We're going to use fundamental identities to evaluate trigonometric functions, simplify expressions, and rewrite expressions. So, on your book, on your notes, are these identities. We're going to start off with the Pythagorean identities. Now, I could go through and try to derive each one of these, but I really don't feel like it. But what do these look like they come from? Pythagorean theorem, right? Because if we were on the unit circle, sine is my y value, cosine is my x value, equals radius, right? Which is 1 on the unit circle, right?
Yes.
Yes. That means making them happen, like showing you where they came from.
So like you just take y over.
It is not used in the calculus sense, as in taking a derivative.
That's kind of the question.
Yeah, it's not like that. Okay. All of these are Pythagorean identities based off of the Pythagorean theorem. You need to memorize these. When I say memorize, I mean the whole sheet needs to be in your brain. Because if it is not, you will not recognize it in practice.
And you'll fail.
Are you going to do another thing like the unit circle? Less?
No, you just need to know them. Okay. So sine squared plus cosine squared equals 1. That's easy peasy lemon squeezy. I like to think of this next one in a different sense. I write it as 1 plus tangent squared theta equals secant squared theta. And I like to think of it by an acronym, ITS, ITS. And then 1 plus cotangent squared theta equals cosecant squared theta. I call that co-its, because it's like instead of 1 plus tangent, it's 1 plus cotangent equals, instead of secant, cosecant, right? It's the cos of the its, right? You okay, Sean? Mm-hmm. Okay. Any questions on this? Know them, love them, memorize them. Be able to recognize them. Reciprocal identities. These are things that you already should know, right?
Yes.
The reciprocal of sine is cosecant. The reciprocal of cosecant is sine, right? And so on and so forth. Okay? You should already know these, have these memorized. This is what they're going to look like and how they'll appear in the wild. Ratio identities. Tangent is sine over cosine, and the reciprocal of tangent is cotangent. So that is cosine over sine.
Makes sense to me.
Yep.
Okay, easy peasy lemon squeezy. Okay. Even and odd identities. Okay. Now, you know how even and odd functions look, right? And even functions are symmetric with respect to the x-axis, so f of x equals f of negative x, right?
Yeah.
Which is why cosine is even. Oh,
It's only symmetrical over the y.
right. And the rest of them are odd, right? So f of negative x equals the negative of f of x. Okay? So cosine and secant are even, the other ones are odd. Now, this is nice because you have if you have a negative stuck in your parentheses, you can take it out by using one of the even or odd identities and make your life a little bit better. I like this slide because I use it kind of like a Prezi. I just zoom in on the parts I want to talk about. Do you guys remember what a Prezi is?
Okay. Not really. No.
It was that thing that zoomed in and out.
Oh, I know what it is.
I thought that was just a PowerPoint.
Yeah. Co-function identities expressed with radians. So if I have sine of pi over 2 minus x, that will be equal to cosine, and vice versa. Cosine of pi over 2 minus x is equal to sine. Now, you probably won't recognize these except for you can see them on the graph. You can see that sine is kind of cosine moved over by pi over 2, right?
Yeah.
To the right, okay? So that
Yeah.
makes sense, okay? So tangent and cotangent and secant and cosecant work the same way. Here's the same thing with degrees.
I've seen that.
Yeah, okay. So we are going to have lots of different types of problems. You're going to have 2 sets of homework for this. There's going to be one that I require you to do first, and then the next one you could do second. Because if you try to do the second one first, you're just going to be struggling. The first one is meant to build up your skills so that you can do the second one. Okay? So let's look at something like this. If cosecant of an angle U is equal to negative 5/3, and cosine of that same angle is positive, find the values of the other 5 trigonometric functions. So if I start with this, you guys should have this on your notes, right?
Let's say U takes place that little weird circle. The line.
That little weird circle is theta.
Does U take place?
The whole unit where that was like.
No, anything can be put there, X, whatever. It's just always an angle if it's there.
So the U does take its place.
There's no taking its place. U is the variable we are using. Sometimes we use theta, sometimes we use X, sometimes we use T.
It's like substituting it instead of.
It's not substituting because I'm defining it as the variable that I am using
Okay.
for this problem. It's a different option. There's no substituting here. Because when you say substituting, it makes people think that there's a mathematical operation.
Well, like English.
No, math has very precise language, and we cannot use one term for another.
Okay.
Notice I did not use the most concise wording of that, which would be substitute. Okay, so if cosecant of this angle U equals negative 5/3 and cosine of that same angle is positive, find the values of the other 5 trigonometric functions. You've seen problems like this before, right? What's the first thing I need to do?
Figure out what CSU looks like.
Triangle, do I need to have quadrants or anything like that? Oh, yeah, quadrants help a lot.
It's going to be in the first quadrant.
No.
It will not, it'll be hypotenuse over opposite.
Okay. Where is cosecant negative?
Second and third quadrants.
Second. How about
Oh, second.
third and fourth quadrants?
Okay, what am I doing?
Where is cosine positive?
First and fourth.
First and fourth. Where do these overlap? Fourth, right? Because I said and, so I need to look for the overlap. So I can draw my triangle in the fourth quadrant. Now, here's my angle U, okay? Which side lengths am I given with -5/3?
Hypotenuse and, opposite.
And so my other side length is 4. Very good. Pythagorean triples, right? Okay. Okay. For your sanity, what are some other Pythagorean triples?
12, 13, and
5,
okay.
12, 13, right?
6, 8,
And-
and 10.
And that's a multiple of 3, 4, 5.
24, 25.
7, 24, 25.
What the heck?
How about 8, 15, 17?
We'll need to know. Hey, you got a 4 off.
Is there like a pattern?
No, it's just, that's just how it is.
Can you
Just
identify?
memorize it. Why am I asking you to memorize this?
It'll be easier.
You really want to do well on your ACT in 2 weeks, and this is going to save you time.
Do they have a lot of
Yes.
Yes.
Yeah. I took an ACT the other day and I went like
Yeah.
crazy on the math.
Also remember the 6
And I got
and
the last
30
10 questions wrong.
in the 45.
Oh, well, if you need help on that, bring it in and
Well,
we'll...
I just ran out of time. I had like a minute to do 10
Oh,
questions.
okay. Okay, so sine of u, cosine of u, tangent of u, we know cosecant, secant of u, and cotangent of u. So sine is going to be
-3/5.
-3/5. Cosine is 4/5. Tangent is right. And then we do the reciprocals. Easy peasy lemon squeezy.
Yep.
So always start by identifying the quadrant you should be operating in and then drawing a triangle if you're solving these problems. Okay. Use the given values of the trig functions to evaluate other trig functions. So we've got tangent equals square root of 3/3, and cosine equals negative square root of 3/2. So I'm going to draw my coordinate plane. Which quadrant am I operating in?
Third one.
Yeah, because tangent's got to be positive. So that's going to happen in the first and the fourth, right? Or first and the third. And then we want cosine to be negative, so that's going to be definitely the third quadrant. Okay, so I'm drawing just my generic triangle. Angle X. Now, when I see square root of 3/3, what does that kind of look like?
Square root of.
So this is my sine x, this is my cosine, so this is my y value, this is my x value, but this is a radical that's been rationalized, right? What would it look like in its unrationalized state?
Square root, no, it would be 1 over square root of 3.
1 over the square root of 3. So 1 and square root of 3, right? Both of those negative. And then this would be 2, right?
Oh, that's how you do the back page that test. I just figured it out.
Special right triangle.
Now, we've been doing these since about lesson 3 or 4. Yeah, so it's a special right triangle. What angle? Well, we don't really care what the angle is, okay? So I need to know sine of that cosecant. We know what cosine is. We need to know secant and cotangent. So sine is going to be negative 1/2. So cosecant is negative 2. If cosine is negative 2 over the square root of 3, then secant is,
Negative 2 over square root.
right. And if you rationalize that denominator, it will be negative 2 square root of 3 over 3. Okay? So, and then cotangent is going to be,
It'll be
The opposite
3
of-
over square root of 3.
if this is 1 over the square root of 3, then cotangent is just square root of 3. Okay? See why it helps you to recognize them in rationalized and unrationalized states?
Yes.
Oh my goodness.
Yay, sophomores. Okay,
It's a lot of juniors that haven't tried it out.
I can't argue with that. Simplifying trig expressions. Here is where we are looking to take our trig identities, which is why you have them on your notes, so you can look at them and recognize them. And we're trying to kind of get all the terms down to just as little as few as possible, right? Okay? So if I'm looking at this, one of the techniques that we can use is to turn everything into either sines or cosines.
Yeah.
Okay? So cosecant would be,
1 over sine.
and tangent is, yeah, sorry, I need to put a theta in here. Sine theta over cosine theta, right? And secant is 1 over cosine theta, right?
It's just like chemistry.
Yeah.
Oh. Oh, yeah. Sure is. Isn't it?
Oh, then you can cross out both the signs. Why are you so condescending with that?
And so we have 1 over cosine theta plus another 1 over cosine theta, and that gives me
1 over cosine.
2 over cosine theta, which is 2 secant of theta.
No way. So you just get rid of the fractions.
Yeah, at the end.
And it's actually kind of easy.
These are fun. I love doing these. This is one of my favorite
Here we
chapters.
go, dude.
This is chemistry. This is so reminiscent of chemistry right here.
What do you call this? Stoichiometry. Yes.
For AP chemistry.
Actually, wasn't that bad.
No,
Yeah.
these are pure logic puzzles.
You get a lot of
So we're
stuff,
just
right?
trying to see what we can do.
Like,
We're just trying to see what we can do with them and kind of,
Just wiggle them around till.
yeah, yeah.
You getting this, Deontay? My dad is in here. He's not
Deontay, if you
listening.
can hear us.
Well,
Come back.
he's going to watch it later. I'm recording it.
But is he gonna watch it?
Deontay,
I'm not watching it.
Please save us.
Okay,
Deontay Batiste.
okay. Next one.
Deontay.
Another thing we can do is distribute or FOIL out our trig expression. So binomial times binomial, we can distribute.
We sure can.
Okay? So 1 times 1 is
1.
1 times negative cotangent squared.
Cotangent squared.
Negative sine times 1. And negative sine squared times cotangent squared is positive sine squared cotangent squared x.
Oh, you don't have to put it in like little parentheses like you did on the test.
What?
Like you like it was like sine, it would be like
What?
sine of cotangent.
You're really so
is like
strong.
3. And then you have to no.
Okay, now, are there any trig expressions in here?
There's
Yeah.
3. 2 different ones. Cotangent.
Yeah. Are there any Pythagorean identities hanging out?
I think actually.
Number 1.
Not really.
Yeah, no, because there's no flex.
No? Okay.
Why are there only 3 Pythagorean theorem identities?
Yes.
Why are there only 3?
Um,
The way it is.
yeah. So one thing we could do is look at these two terms and see how they have a sine squared in them.
Yes, on that.
So if I pull out a sine squared
Wait,
and
is that-
undistribute,
The negative cotangent squared x is multiplied with negative sine squared x, right?
oh yeah, if I do that, I'm just doing factoring by grouping.
It's got less easy very quickly.
Sorry. Yes, this got less easy very quickly.
It's all your fault.
Okay, so could we possibly turn everything to sines and cosines? Yeah, let's try that. So cotangent is 1 minus cosine squared over sine squared minus sine squared plus sine squared times cosine squared over sine squared. Okay? Oh, I forgot my x's. So my sine squareds cancel out, right? And I have 1 minus
And just for
cosine squared x over sine squared x minus, ooh, I might want to have like common denominators, right? That might be a good thing to do.
yeah, maybe. On phones.
Sometimes you just got to try things and see if it works.
So you go to test. Let's try things, see if they work.
Realist question.
Yeah, which means step 2 is kind of like pointless.
What the free?
Possibly.
So step 2 won't be on the test.
Oh. Square value. Is that a sine to the 4?
Why, yes, it is.
Isn't that
Looks
something?
like a fun number. You want us to raise 2?
Yeah.
Step 2?
Dude, so what is like the easiest part of this?
It's easy.
Lol.
Exactly like this.
Okay. Is there anything we can do with this? Sometimes these just get really wonky, don't they?
Yeah.
Hmm?
Well, we got
Is that a T or a Y?
Hold on.
That-
There are things we could do because there's the sine squared x
Mhm.
over sine squared x and the negative sine.
Well, yeah, but I just made those. I just built those up so we could have common denominators.
Yeah.
So we've got sine squared x minus cosine squared x minus sine to the 4th x. This is just not looking good, is it?
Oh,
No.
I'm already running out of room to put this.
Yeah. Hope you're not writing in pen.
Not tell them, don't tell them what time lunch is at.
Okay.
I'm not that hungry again.
It's been 4 months, you should know what time lunch is.
Yeah.
You see that?
Hold on.
You never eat work. You ask every single day when the first hour ends.
It's never changed.
Really?
Every day. Every day, I do so much shit, but it's like,
What time?
You need to borrow. No, I haven't.
Okay. I'm seeing if I distribute. So, you know, oh, here's what I should have done. I'm seeing it now.
My wrist didn't take much more.
If we were looking at our Pythagorean identities, sorry, sometimes they hide, right?
Oh,
what about?
so we have to redo this again.
So like, what do we do with that information?
Yeah. 1 minus sine squared would be equal to cosine squared would, right? Sorry. I was leading us down a merry path and illustrating what happens when you get down the merry path and you realize I still don't have anything, right?
Wait, how do you know?
How do I know I don't have anything?
No, like 1 minus sine squared x is not on that thing. Is that, if you
Okay, look at your Pythagorean identities
like, you open the cosine over?
and move the sine over, and what are you left with?
Oh, 1 minus sine squared.
1 minus sine squared is cosine
I just
squared.
had to erase all this.
Yeah, I'm going to do that. Yeah, and unless you doubt me, this sometimes happens to you, so it's okay.
It's gonna be fun in the recording. He's gonna write this
Such
all
a
down.
full erase.
Yeah, it's going to be horrible, and he's going to be like, Miss A, why did you do this to me? Okay,
You're gonna be crossing out, yeah.
Yeah,
That
yeah.
just equals
The classic
cosine
Dave.
squared.
yes.
Okay.
So I'm going to have cosine squared minus x, right, minus cotangent squared x plus sine squared x cotangent squared x. Okay, so now we've got some stuff gone, right?
And then you can use
Write this in my notebook.
And
I'm just gonna just that for a bit more than.
Yeah, he said it's just not possible. If they tried, but it just.
yeah, I think that's probably about it.
Well, you can transform the cotangent into like cosine x, or sine x, right? You can cross out the signs and then just do up the cosine squared x plus cosine squared x.
Oh, yeah, so cotangent, when we take sine squared x times cosine squared x over sine squared x, right?
You're just left with 2 cosine squared x, right?
And that's going to be 2 cosine squared x minus cotangent squared x. Yeah, I think we're good.
Okay, where'd the cotangent come from? There's always the other one, there's 2 of them?
Yeah,
Oh, yeah.
that's what happens when you distribute.
Did you ever rotation?
Okay, so yeah, I think I'm satisfied with that. I don't think there's anything more I can do with that.
It just didn't work out well.
You can't do like cotangent or cosine over sine and then try to do that again.
Yeah, let's not.
Okay.
That just puts fractions and things, and that's not really simple.
And also, all lots of school's fault. School's really full.
Okay.
Wait,
Whoa,
please.
sorry,
I have to write down a whole lot.
That's a lot to write.
sorry.
I actually carried on that one question.
No, you did not.
What, you can't write as fast as me?
No, that one part.
I'm just
where I
messing with
did
you.
Cosine over sine, I actually carried.
Consider how to transfer to my notebook? No.
Considering you weren't going to write it down again until I said it was good.
I'm not writing this question down.
Still
Like,
carries
I'm sorry.
I broke trust with you.
If not worse.
If not worse.
Okay.
Dude, Mr. Riggs actually gets mad at him every day.
Oh, it's hilarious.
Gets mad at who?
Even him.
Because he doesn't, it's not like he just talks out of turn and like interrupts class. He asks questions that are like,
The worst question.
he'll ask like Gandhi showed up on screen and he was like, instead of asking a question about like whatever Gandhi thought about, of whatever, he was like, why is this color so high?
So Ethan, there's a term for that, and I need you to look this up on Google and tell me the definition of this.
Is it nuts?
Inane.
Inane?
How do you spell that?
I don't know this stuff.
Go look it up.
Look that up.
I think it's like really dumb.
Question's not meant to be asked.
Redundant.
Shouldn't be asked.
Silly, stupid. That's what shut up when I Googled it.
So you need to learn these words so that you too can use them in sentences.
So you don't appear inane.
Right.
And the quote for that word is, don't constantly badger people with inane questions.
Wow.
So,
That was on the way to the calendar.
So that's the most we can do with
that's
that.
the word of the day, inane.
That is
I
the
know
most we
there's
can do
another
with
word
that
that I'm
right
trying
there.
to think of, and there's an actual word for it, and it's to throw someone, to actually throw someone out a window. I think it's defenestration.
Defenestrate, yeah.
Yeah, defenestrate.
Have you looked at it? Alfred?
Another thing is that I like to use is capricious.
I'll check. I'm probably gonna ask
What's
you that.
capricious?
Look it up.
Check what weird it is. That's what my dad doesn't look. I know that.
Capricious.
Should I get like his background information? Like all his cases? I'll be like 0-50.
Okay, we good?
What? 0-50 for like.
Another thing you might have to do is factor your trig expressions.
The worst lawyer was.
Okay? So if we were looking at this, we have something squared minus
I think like a boxer.
something squared, right?
Oh, that's like a.
Just do cosine x minus 2 times cosine plus 2.
What are those called in like
Difference of
quadratic
squares.
Squares, yep.
Mm-hmm.
You just left with cosine x squared.
Are you kidding
Oh, you
me?
could have just done that by dividing down too.
We might have
You
had, like,
could've.
a fighting chance on the test, this test.
Well, don't say that now, you're doing jinx us.
What if we had 4 tangent squared theta plus tangent theta minus 3? How would that factor out? Here's a technique that you can use if you can't see it. We're going to let u equal
Oh.
tangent of theta. Then this becomes 4u squared plus u minus 3.
Yeah, I remember this.
No.
You
Like,
might try to make you and then you just stop you and let it be.
If I have 3 and a 4u and a u and a 1, and this is a minus and a plus, I think that works out, right? So this factors to 4 tangent theta minus 3 times tangent theta plus 1,
So I can treat a tangent like
a variable.
variable.
Yeah.
Just like-
That helps you factor trig expressions more easily.
Huh. Okay. Are we ever gonna have to graph these, by the way?
Yes, probably.
That is one way that you can check to see if your expressions are equivalent. You graph the thing you started out with, graph the thing you ended up with, and see if they match up. If they didn't, you made a mistake algebraically somewhere.
What happens if you put it into those bounds?
It graphs,
Graphs like what?
like whatever it is.
If you put it into definite.
Yeah, but the question was.
If you have that question, why don't you go do it and see what happens?
Sorry, I'll do it then. I wanna see if like this is trash.
Okay. Something that we sometimes have to do is to add fractions.
You skipped over an example.
Huh? We did?
Yeah,
Cos-
simplify the expression, code 3.
Cosine of to the 3 to the cube.
Did
cosine
I?
cubed of x.
Whoops, you're right, I did. Let me see if I got it somewhere else.
Sine to the square x.
Okay, that works. I'll add that in.
We should just
It's
move.
big.
Huh?
Never do
It just means essentially move.
Never again.
Yeah.
You ever do operator? With Lucid.
Okay, so we've got, simplify the expression, so we've got cosine cubed x plus cosine x sine squared x. So how could I simplify this? I could GCF factor a cosine x out of it, right?
Yeah.
And then I'm left with cosine squared x plus sine squared x, which is
Oh, that's an identity, right? That's
equal to 1, so this simplifies to cosine
This
x.
is just algebra, pretty much. Right? Like, we're not doing anything really silly, like,
But you have to use your identities and substitute them in and use them to simplify things.
so like if I replace,
You just kinda like
I like this unit. Like, they were
I
far
like it
away.
more than unit circle world.
unit circle is kind of dastardly in the left center.
Okay,
That part, yeah.
next. Now we're adding trig expressions, but we need to have common denominators, right?
Yeah.
Do it with tangent parabola. Because you told me to graph it.
Oh,
So it makes parabola.
nice.
Okay.
So I'm going to multiply this by the other denominator over itself. So secant x minus 1 over secant x minus 1. And secant x plus 1 over secant x plus 1. Now, when I multiply these two denominators out, that's going to give me something different. Because we're going to have secant squared minus 1, right? And on the top of this fraction, I've got secant of x minus 1 minus secant of x minus another 1. So this is going to equal negative 2 over secant squared minus 1, which is,
Wouldn't it be positive 1 for second secant squared?
Oh, I said
Six.
there's a minus in the middle that I have to distribute.
Oh, yeah, you're right.
And 1 plus tangent squared is equal to secant squared, right? So secant squared minus 1 is equal to tangent squared x. And then this is going to be equal to negative 2 cotangent squared x. Easy peasy lemon squeezy. Not so much, but you'll get there.
And take spraying power load.
Yeah,
Yeah.
makes sense. Hold on, give me like 1 sec though.
You can find us.
Okay.
Ethan Fontana. Find us.
Where did you get 1 plus tan squared?
Look how horrible this group's at.
It's a Pythagorean identity on the top of your page, top left.
Where is that?
It's something that I recognized.
Oh, that's
Right.
Yeah, that's so crazy that little test that, or that Anna figured out little test that was trying to get with him. and she called him
We're
little test.
recording this.
Oh, you're right, I forgot about that.
It's fine. Poor little Ted. She did. She called it a little test.
Two.
Okay.
He did this as well.
Oh, I skipped another one in here.
No, really?
I must be using an old presentation again.
Did you
Okay, so example 8 is simplifying by writing and using identities. We're going to simplify the expression cosecant x minus 1 times cosecant x plus 1 over cosine squared x. So how can we simplify this?
I don't think that's how you do. Different squares, no.
Difference of squares, right? We're going to multiply it out, and we end up with cosecant squared x minus 1 over cosine squared x, right? After distributing all that, right? Do I need to show you every step?
No, that makes sense.
Okay. Because they're conjugates of each other, right?
Yeah.
So what is cosecant squared minus 1 equal to?
1 over sine, right? Well, no.
No, it's probably an identity.
Exactly. Is that
Equal to cotangent squared.
Whoa.
Okay.
Whoa.
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 So now what do I do?
You can split the cotangent up into sine or cosine or sine, right? And then you can multiply times cosine.
Oh.
Ethan is in his element right now. Yeah. Ow.
Right?
Yeah.
Now we flip and multiply.
Yeah. So I forget that.
Right?
Yeah. Huh. Wait, hold up.
I'm holding.
Double checking things. This won't be available in school together. Just double checking. Because I know you used to upload notes.
I've uploaded notes every single day of this course.
Okay.
And if I forget, let me know.
Okay. Alright.
Okay.
How do you get rid of like this little square thing?
Like the rule two.
You don't.
You know?
Like, but how would you solve for that then?
Did I ask you to solve for anything?
No, I'm like curious.
There's nothing to be equal to.
Don't be curious.
You can't solve it.
Be George.
There's no equal sign.
Are you even doing that though? Just using-
Solving?
Yeah.
Yeah.
Okay.
We're just teaching you how to deal with each side of the equation.
That old man.
Okay.
You know. Why? You blew it was at the right time?
No, you gave it a stupid little note.
A note?
Yeah.
Okay, you guys with me?
I wrote it.
It was over before he began.
He edited it for himself.
Can't believe he gave her a note. Oh my god.
You meant to put it on get it to her on Valentine's Day, but you chickened out. That's what Riley told me.
Imagine you commented on a Strava post, dude.
Think about it on the shelf.
How does Riley know?
I think 'cause Aunt or something.
You guys with me? Or you just kind of,
No, we're there. I'm there.
okay.
I'm ready to go.
'Cause, like-
Oh, I've been there.
I'm like blocked.
All your little stories, all they do is like distract me.
Oh, okay.
Okay, I actually know how to do the math today.
Good, good. Okay,
I'm just gonna listen back on the recording and hear all these random stories.
Here's my-
yeah.
Wait, you just
Yeah,
skip
yours
through it
are
because
really
like
nice.
if he has a.
This needs to be just like normal.
So we're going to use trig substitution to write this expression as a trig function of theta, where theta is between 0 and pi over 2, which means we're in the first quadrant, right? So I'm just going to draw my first quadrant here, okay? And x equals 2 times cosine of theta, okay? So if I were to look at x equals 2 cosine of theta, And I needed to draw a triangle with this. Okay. Then x over 2 is equal to the cosine of theta. And theta is equal to the arc cosine of x over 2. Okay? So theta is going to equal the inverse cosine of x over 2. Now, cosine is adjacent over hypotenuse, right? Which means the remaining leg here, x squared plus something squared
Oh, that's
equals 2 squared,
nice to.
is going to be 4 square root of 4 minus x squared, right?
Yeah.
Okay. So, we need to write this expression, 64 minus 16x squared, using that. So if I look at 64 minus 16x squared, hold on. Hopefully I didn't do this wrong. Yeah, okay. If I pull out a 16, right, I'm left with 4 minus x squared. So that is 4 square root of 4 minus x squared, right? And
Or x minus 2 and x minus plus 2, right?
what?
Then you're left with x minus 2 and x plus 2. You split them up.
No, I need to write it as a trig function of x, right? But I need people to like be quiet so I can think about what I'm doing, because this doesn't just come,
Quiet analysis.
yeah. Please?
Oh, yeah. I've been paying attention
Okay, yeah, but what did I say about all your stories? They distract me.
I'm sorry.
This is not the easiest thing. Please don't distract me. Okay, so we need to look at this expression as, hopefully I'm not messing this up, 4 minus x squared, and let's see, if I look at 2 tangent squared, so x equals 2 cosine squared. Oh, okay, sorry, that's where I make my substitution. So 4 times 4 minus 2 cosine, sorry, this should have been a square root.
Where'd this go?
So in place of x,
Oh, okay.
I'm writing what x is equal to. 4 minus 2 cosine theta squared. So this is square root of 4 minus 4 cosine squared theta. Okay, 1 minus, if I pull out another 4, this is 1 minus cosine squared theta, right? Which is
An identity.
an identity. Square root of 4 is 2. 4 times 2 is 8. And this is square root of sine squared theta, which is just going to be 8 sine theta.
I haven't played this many square roots in forever.
This one was a little tough.
Yeah.
So we're like, yeah, these are never my favorites.
This is going to be the easiest to get for the entire year.
This is something that you have to It shows up every once in a while in calculus, so we have to teach it to you.
Will this be on the SAT or the ACT?
Absolutely not.
I would hope not.
No.
Okay.
Well, they had those weird little matrices. How do you solve for those? The matrices?
The determinants. So if you have A, B, C, D, and you want the determinant like that, it's AD minus BC.
I'm just scrolling it, dude.
Oh no, it like told it how to like redo it. Like it was like, what is a similar matrix to this?
Oh, dude, that's just, the matrices are just coefficients for.
Yeah, for
system of equations.
Oh,
yeah.
okay.
But sometimes they give you just naked math and
You
no,
guys test notes on that test?
no.
No.
So when we go to take the ACT, y'all need to
Lock in.
check calculators out.
Online?
Oh, I can't
Just
use
about.
those.
Miss Aldridge, do you have a Sharpie, mine? We got a, Mr. Rick sent 2 Sharpie. Because I wanna write my name on my calculator and then charge it a little bit.
Oh, here, I've got a special one for that. It's a paint pen.
All I have is, is it the oil one?
Yeah, it's a metallic paint marker.
The oil ones work so good.
And it's silver. Anyways, okay, we're gonna stop the video, so we will come back after lunch.